An infinite geometric series is given by this. So summation of k equals to 1 to infinity of 2 times 4 minus 3x to the power of k. So for part A, find the values of x such that the series has a finite sum. The series would have a finite sum only if the common ratio, the absolute value of the common ratio is less than 1. So that means the series should converge. So in that case, if I talk about the value of R is, we can find it by the second term over the first term. So here, how do I find the first term is? So in order to find the first term, we can put the value of k to be 1. When we put k as 1, so we would get it something like 2 times 4 minus 3x to the power of 1. This will be my first term, and the second term is going to be 2 times, so we have to put the k value to be 2. So 4 minus 3x to the power of 2, and it goes on. So this is how the series would look like. So in that case, R, we can always find that by the second term over the first term, where R is the common ratio. So that's going to be 2 times 4 minus 3x whole square. This will be my second term over 2 times 4 minus 3x. So if I simplify this, 2 and 2 can get cancelled out, 4 minus 3x and the square can get cancelled out. So it's just going to be 4 minus 3x. So R is the 4 minus 3x. So in that case, the absolute value of 4 minus 3x has to be less than 1. And whenever we talk about this absolute value of 4 minus 3x has to be less than 1. So in that case, how do I solve this absolute inequality? So I can always write this one as this, whatever we have it inside this absolute function, that has to be between this minus 1 to positive 1. So the logic goes something like this. So whenever I have mod x is less than a, we can always write this as minus a is less than x is less than a. So in place of a, we have 1, and in place of x, we have this 4 minus 3x. And now I'm going to, we have to make x the subject or something. So I'm going to separate this. So minus 1 is less than 4 minus 3x. And also 4 minus 3x is less than 1. So I'm going to take this 3x to the left hand side and 1 to the right hand side. So it's going to be 3x would be less than 4 plus 1, which would be 5. So in that case, I'll be getting x is less than 5 over 3. And if I talk about this one, so I'm going to take this 3x to the other side, 1 to the left hand side. So 4 minus 1 is going to be 3 is less than just 3x. And 3 goes to the other side, so it will get divided by 3 over 3 is going to be 1. So in that case, I would say I can also rewrite this as, so we are talking about x has to be greater than 1, but it has to be less than 5 by 3. Or we can also say it as x is between 1 to 5 by 3. And this is the right answer for part A. Now, if I talk about part B, when x is 1.2, find the minimum number of terms needed to give the sum which is greater than 1.32a. So we are talking about the sum of the term. So the sum of n terms in a geometric series, the formula would go something like sum of n terms is going to be a into whenever the value of r. Okay, first of all, let's figure out what is the value of r is. The common ratio, we know the common ratio is going to be 4 minus 3x. Now, when x is 1.2, so it's going to be 4 minus 3 times 1.2. So if I simplify this, so 4 minus 3 times 1.2, so we will get the value of r to be just 0.4. And also if I talk about what is the value of a is the first term. So my first term would be 2 times 4 minus 3x to the power of 1. So in that case, if I substitute the value of x to be 1.2, because they have said the value of x is 1.2, so in that case, it's going to be 2 minus 4 minus 3 into 1.2. So this one, so we would get the answer to be 0.8. So now, whenever the R value is lesser than 1, so we always use the formula for the sum of n terms to be 1 minus R power n over 1 minus R. Now, the question is talking about the sum of n terms has to be greater than 1.328. So the sum of, for what value of n, this is greater than 1.328. So that's what we need to find out. So in that case, if I substitute this information in the sum of n terms, so that's going to be, a is nothing but 0.8 times 1 minus 0.4 to the power of n, and entire thing divided by 1 minus 0.4, which is nothing but 0.6. And this must be greater than 1.328. And we have to use our calculator to solve this. On the calculator, so whenever we have any equation for inequality, so we would always graph both the equations and figure out what is the point of intersection is. So first of all, the left-hand side equation. So whatever the equation, we have it on the left-hand side, so we can draw that. So it's going to be 0.8 times 1 minus 0.4 to the power of, instead of n, I would be using x, and this divided by 0.6. This is what we have it on the left-hand side. And the graph is going to look something like this. And on the right-hand side, we just have this 1.328. And the graph is going to look something like this. And we need to figure out where is the point of intersection. So I can also zoom in a bit more to understand how the graph looks like. Yes, so here is some point of intersection. So that point of intersection, we can find it by analyzing the graph and the intersection. And yes, so here is the point of intersection. So now, when the value of n is greater than 6.03, the blue graph is going to cross the red one. So the summation, this s of n would be greater. So which means n has to be greater than 6.03. So here we are talking about n as being the number of terms. So when does the sum of how many terms would be greater than this 1.328 is? Definitely it cannot be 6, because the sum of 6 terms would be lesser than 1.328. So that is the reason the value of n is 7. So we need at least the minimum number of terms needed is 7. That is the right answer for part B.